To solve this equation by completing the square, we want to take this side and be able to factor it so it is the same factor times itself. For instance, if we have the number 81 and we factor it, we can turn that into 9 times 9 because this is a perfect square, so we can come up with the same factor. So we know what a perfect square is. We want to make this into a perfect square. The way it is right now, it will not factor into the same binomials times themselves. For instance, if I said x squared plus 6x plus 9, if I factor this trinomial, it gives me x plus 3 times the quantity of x plus 3, or x plus 3, this quantity squared. So this is a perfect square because it's got factors. Its two factors are the same. Just like 81 is a perfect square. So 9 times 9, 9's the square root of 81. So we want to turn this into a perfect square trinomial. So what we have to do is we're going to have to add an amount to it in order to get that. And I'll show you where that amount comes from here. I'm just going to bring up the algebra tiles here. This is the same equation. I've got w squared plus 28w's plus 52 here. So when we're looking at factoring here, we can take this. I don't know if they use the algebra tiles in Algebra 1 still or not, but we're going to take this and we're going to put our w squared here. And the way this works is, this side, this expression that we end up with here, times the expression we end up with here, gives us this product out here. So we've got a w squared, and what we're going to do is we're going to take, since this is our product, we want to take these and we want to split them up over here. So I've got those ones on this side, and let's see if I can take these ones, and I think there's a way to, yeah, we got to move all these ones in over here. Would have been nice if they would have done it all at once, but we'll work with it here. So what we're essentially doing though is that middle number that we had was 28, and because it's even, it makes it a lot easier, and hopefully, starting out here, they have a lot of even values. So let me move all this down. Let's see if I can move this chart down a little bit. Oh, well, even though I can't move that chart down, I don't have enough room to fit them all on here, but we're going to do it like this. So right now, the dimensions we have here are w. The length of this is w by w. That's why we have w squared. So this is w. The length here is w by 1. So we've got right now w plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And because we split that 28 in half, we also have w plus 14 over here. Now, in order to complete the square here, and like I said, this is all going to kind of go off the screen a little bit because it won't all fit on there, but just pretend with me that it does. We're going to take our 52 here, and if I wanted to add in all these units into here, I'd have 52 units, but if I want to fill up this square, so I have a perfect square here with everything added in, we're going to have to add in a bunch more units here. And the amount that we have to add in is going to be a 144. So if we look here back at the actual problem we have there, we need to take this, and if you're looking at like it's a generic rectangle, I think a lot of the Algebra 1 classes are still factoring it using this. Ooh, don't judge my rectangle. But we have our w's squared, and we took our 14 w's from half of it. We put 14w here, and we put 14w here, which meant that the dimensions of this are going to be w, w, because w times w is w squared, just like we had on the algebra tiles. And then w by 14, so w plus 14 there, would give us our 14 w's, and then w times 14 would give us 14w. So now that we have w plus 14 and w plus 14, you have to look at, well, if this is 14 units long and this is 14 units long, that means the same about these two sides. 14 times 14 is going to give us 196. So the number that we really need to have right here for this to be a perfect square trinomial is got to be 196. So we look at what do we have to add to 52 to get to 196, and that's going to be, 196 minus our 52 is our 144. So we have to add to the side of the equation 144, and then we have to do the same thing on the other side. So we're back to now w squared plus 28w plus 196 equals 144. The whole reason we did that there was now this is a perfect square trinomial that will factor into something times itself here. So we've got this factors into w, so and we're going to have plus 14 plus 14. That equals 144. And then we can rewrite that as w plus 14 squared equals 144. So now the whole solving process gets easier for some people. Some people don't like doing this part of it, but we can take it and just do the square root of each side, because now they're both perfect squares. This is a perfect square, and so is this number. So we get the square root of 144 is 12, and the square root of w plus 14 squared is the absolute value of w plus 14. And the reason why you have to put in absolute values is because when you think about some number squared equals 144, that could be two possibilities. You could end up with putting in there 12 squared equals 144, but you also have to consider the fact that negative 12 squared equals 144. So what this really breaks down to, and some Algebra 1 teachers skip over this, which drives us crazy in Algebra 2 because then none of the kids understand it, but w plus 14, this value inside here, could equal 12, or w plus 14 could also equal negative 12, because either of those values could be in here to make that a true statement. And then that's where they solved it the rest of the way and got w equals negative 2, or w equals, what is that, negative 26. But just to go back to your question, where does 144 come from? We have to make this into a perfect square trinomial. And in order to do that there, if we have 28 w's in the middle, we know we have to split those in a generic rectangle, or if you're looking at the algebra tiles, you have to put half of them here and half of them here, which would then leave us needing 144 more single units here in order to fulfill this actual square, this diagram. In the generic rectangle, you just see it as just the math. 14 times 14 gives you 196. So to turn 52 into 196, we have to add 144, and then we have to add 144 on the other side. Hopefully this helps. Let me know if it doesn't. I don't know. Okay. All right. Hopefully it's not too long. Bye-bye.